Our last reaction for carboxylic acids is the formation of amides. This one is actually a little bit difficult in the fact that you have to recognize what's going on, because sometimes I'll try to fool you. Because right away, this first prompt, you should recognize that I have a carboxylic acid over here. Remember, it's an acetic acid. And I have an amine to react with it. But remember, amines are basic, right? In nature, right? That nitrogen can act as a base. So in reality, if you see this prompt that I just gave you, you have a carboxylic acid and a base. You should actually just do an acid-base reaction, right? The product of this is going to be a carboxylate anion, and then I'm going to transfer a hydrogen and this is a reaction from last chapter, right? Because I'm going to have this positive and negative, right? I should be able to name this thing, but that's an ethyl ammonium acetate. But again, this is not an amide, right? This is just a acid-base reaction, and that's what would normally occur with these molecules in a test tube, right? Now, in your body, where you have enzymes that can allow other reactions to occur, even though it's most likely that this acid-base reaction would occur, if given these two molecules, something else may occur. But if you wanted this to happen in a test tube, if you want to make an amide in a test tube, you actually have to change up your carboxylic acid a little bit. I'm going to have to make this to get the reaction that I want, right? This is going to be called an acid chloride. And we may be able to name that more specifically in the future, but for right now, you just have to say acid chloride, right? If I had this and I reacted with that same amine from above, I can do a different reaction. And this is the reaction that I'm concerned with. This is that formation of an amide that we're supposed to do at the end of the day. So you're just going to have to be careful. If I don't give you an acid chloride, you're actually just going to do an acid-base reaction. If I give you an acid chloride, like I did in the second prompt, you can create an amide. And amides are fairly simple to create. All I have to do is take this chlorine and one of these hydrogens to make a stable byproduct. Again, I'm just going to make that hydrochloric acid over there. It's kind of like removing a water in our last reaction for esters. And then what's left behind just needs to get connected together. So what's left over when it's all said and done is basically like an aldehyde-looking functional group. And then I have a nitrogen down here that's still connected to two carbons, and it still has one hydrogen on it. But those two atoms that were removed, between the two atoms that they were connected to, there should be a new bond, right? And that bond is my amide bond, right? This functional group here, again, it looks kind of like an ester, but it's a nitrogen instead of an oxygen. But that bond is an amide bond. That's really important in biology and biochemistry because that's how you make proteins, right? You link amino acids together, making peptide bonds, which are a type of amide bond, and that's how you build those giant structures to begin with. And without proteins, you couldn't exist, right? So this reaction is really, really important. But again, it's a little bit confusing too. It's misleading, right? In your body, this carboxylic acid up here, the acetic acid, and this amine would actually probably make an amide bond. But in a test tube, they don't. They just react acid-base, right? So if we wanted this to happen in a test tube, I'm going to need an acid chloride from the get-go, and then I can make my amide when it's all said and done. So I have an amide over here, and we'll learn how to name that amide later. Right? It's actually not terribly difficult to name, but we're going to talk about it specifically later. So for right now, we can just call it an amide. And then we'll go from there. So if you can do that reaction and understand how to differentiate. If I give you the acid, the actual acid, it should be an acid-base reaction. If I give you an acid chloride, then you're going to make an amide. Now, if I had enzymes, if I was inside of one of your cells, I could definitely take that acetic acid and my ethylamine and create this same amide that I made in the second reaction. But unless I'm in a cell with those enzymes, that's not really going to work. So you got to know when to do one thing, when to do the other. One's technically an acid-base reaction. The other is a formation of an amide, right? So just try to differentiate. Examples could actually be just, I can actually do this with just an ammonia, right? So one of those hydrogens is going to get removed, the other one doesn't. And I'd get just this amino group attached to that, essentially that carbonyl carbon. Still remove hydrochloric acid. So I don't have to have an amine. I could have an ammonia too. And that's how we're going to name these things eventually, right? Because this is going to be called an ethanamide. Or I could call it an acidamide. It depends on which system I want to use, Comet or IUPAC. But, I did an amide like this. So I don't really need to have carbons attached, but I could also have two carbons attached. Right? If I made this a secondary amine over here, it just turned into kind of a tertiary amine over on the right, because there'd be no hydrogens left, just carbons attached to that nitrogen. And then that would be a whole new thing. Right? It's going to be named off of that ethanamide. I'm just going to say N-dimethyl ethanamide. But again, we'll talk about the naming later. I just want you to be able to create that amide right now, and I want you to know when one reaction is going to happen versus the other. Because had I had a hydroxyl group here to start, I would not have formed these products over here. I wouldn't have made this. I would have done an acid-base reaction. So make sure you understand the difference.